Hello and welcome. I'm your host and speaker Vijit Kauda, and I'm MuleSoft developer at Infometry. Thank you for taking the time to join us today. In today's webinar, I will be talking about designing modern APIs in MuleSoft using OpenAPI 3.0. You will live with best practices, design first approach, and real world implementation using OS 3.0 in MuleSoft. Feel free to drop questions on the topic or share your struggles and experiences during this live session. We will answer your queries through chat. Let's start the session. This session is organized by Infometry. We are pure play data analytics company based out of Fremont, California, with our offshore development center in Bangalore, India. We came into inception back in 2010, and since then we have been offering domain-specific analytics solutions for high-tech, energy, life sciences, retail manufacturing, and finance customers. Being a data analytics software services and solution provider, we focus on delivering predictive and prescriptive analytics solutions, cloud data warehouse implementations, data governance, enterprise service bus, microservices based integration solutions, big data, cloud DevOps, Salesforce CRM, and also the product engineering and etc. and so on. So, Infometry has been engineering and consulting services partner for companies like Snowflake, Google Cloud, Informatica, MuleSoft, Databricks, Fivetron, AWS, Tableau, Adaptive Insights, Microsoft Azure, and Material, and so on. Moreover, Infometry has developed 22 plus Informatica cloud connectors and Snowflake native apps with a pre-built connectivity to NetSuite, Salesforce, and Marketo, enabling real-time analytics across Snowflake, Geo, Google BigQuery, Amazon Redshift, Databricks, and also the Azure Synapse. One mentioned under Blue blocks are developed and owned by us, and the rest are all developed by us only for organizations like Informatica, SAP, KLDS, and etc. So we have developed state-of-the-art analytics solution InfoFiscus, which can be hooked to any on-prem or cloud CRM or ERP or planning apps. InfoFiscus is 100% cloud-based pre-built analytics software developed using open architecture. InfoFiscus comes in three different flavors: finance, supply chain, and sales and marketing analytics. So we are delighted to announce the launch of the next generation InfoFiscus Snowflake native applications featuring pre-built connectivity to NetSuite, Salesforce, Marketo, and more. These applications enable seamless integration and real-time analytics. That's our quick introduction, and now let's move on to our today's agenda. So today we'll be discussing about how to design a modern APS using MuleSoft using OpenAPI 3.0. So today I'll be covering about introduction to OpenAPI and why design first MuleSoft and why use like what is the OS 3.0 structure, what is the best practices to for API design using OS, and what is a sample user specification, how it looks like, and also the common pitfalls, and finally what was the conclusion. So here when I say OpenAPI is 3.0 is the foundation for everything we do in modern API development with MuleSoft. I'll start by explaining what it is, why it exists, and how it fits naturally into the MuleSoft system. And why design first in MuleSoft. So here we'll focus on why MuleSoft strongly encourages design first instead of code first APIs. So I will connect this directly to real world delivery speed, governance, and also the team collaboration benefits and how 3.0 structure. So this section breaks down the building blocks of an open API specification. Understanding structure is critical because MuleSoft tools heavily rely on it for automation. And what is the best practices? We'll discuss practically API design rules that actually matter in production systems. So these best practices help avoid rework and improve usability and keep API stable and scalable. And when it comes to the sample OS, so here I will show a sample example of OS with basic HTTP method like get and post, how to utilize, how to invoke, what are the things we need to add it to the using in OS to get the API ready. So I will just explain everything in this section. So in common pitfalls like these are the mistakes I've personally seen in real projects. So knowing this upfront can save weeks of rework and also some issues in we may occur in production in coming in while we're implementing projects. So at finally we will wrap up by reinforcing why design first and open API are essential. So what is OpenAPI 3.0? So OpenAPI is like will bracket it to four topics like here. The first is industry standard for API specification. So OpenAPI 3.0 is globally accepted standard for describing REST APIs. So because it's an industry standard, it tools like MuleSoft and also the Postman and also Swagger, like you can all understand it. And why YAML or JSON based? So OpenAPI specification can be written either in YAML or JSON format based on the user convenience. So because I personally prefer YAML because it's more readable and also the easier to maintain the specs. If you go to JSON, the problem having a JSON is like we'll be having a multiple brackets for each of the um, key and value pair. So that will become very less readable and it is more complex to understand where it started and where it ended. And also the third one is contract first API development. So with Open API, we define the API contract before writing any mule flows. Basically, when we say designing an API, so we'll design everything from starting to ending. So when we get that API like sample API, whatever we are going to do while implementing projects, so it can ensure all consumers and developers agree on the API behavior upfront. And like what is the improved over Swagger 2.0? Basically, the OS is with the Swagger only. So now the MuleSoft is incorporated into the endpoint platform. So now in OpenAPI 3.0 fixes many limitations of Swagger 2.0. Basically, it's add better schema modeling when it compares to Swagger. So in MuleSoft, it has a better schema modeling and also the request bodies we can add and also improved security operations. When we are applying security policies, it can we have in OpenAPI we have like additional things that I will be covering later. So why design first in MuleSoft? So for example, here why if you want to design first in MuleSoft, why we need to design the first step in MuleSoft itself? So like for the one of the thing is the faster development. So when we start designing APIs first, it allows MuleSoft to generate flows automatically from the spec. So if we define everything in a spec in a specification, so when we started implementing that API in MuleSoft, so it will allow us to generate the flows automatically based on what we have implemented in design. So it will allow us to do the faster development when it compares to if we go from scratch, it will takes a lot of time. So once we design first, then we can get that design and generate the MuleSoft flows that will allow us to develop the faster the development that we are working on. And also it reduces like manual coding and also the let's developer focus on business logic basically and parallel work. So front end and back end teams can also work simultaneously using the same API contract because it's been already defined in the design phase. So front end can get what they want by invoking the mocking endpoint that we have generated using in OpenAPI 3.0. So front end can seamlessly use that endpoint to invoke and whatever the response they wanted, like it can also be done until it is completed from MuleSoft end. This avoids dependency on delays and also it keeps project moving faster and reduced work. So a well-defined API contract reduces misunderstanding and changes later. So basically, this saves the time and effort and cost during later stages of development. If we design properly, it will save us a lot of time to like reconsidering or redesigning, and also it saves a lot of effort to go back and forth for the same changes, some changes and all. So and also the cost, so it let us when we are developing it, like it will save all these things. And also the when it comes to strong API governance, so design first enables enforcement of standards through API governance rules. So MuleSoft can validate APIs automatically against the organization guidelines. This is about why design first in MuleSoft. So the next thing is key components in OS 3.0. So when it say like in OS, we divided this into like the components of OS. Like these are all the must and should in OS. So let's say we start with info section. So the info section contains metadata like API name. So basically this info section belongs to us. So whatever the like in info section we can define whatever the details that we want in our API. So if someone comes and sees a API specification, So they can see like, okay, this it is what is this and what is version of the current version that has been exchanged, and what this API particularly do. And so all this information we can add it in a info section at the top of the OS 3.0. This helps consumers quickly understand the purpose and ownership of the API. The second path is path. Second structure is path. So paths define all available endpoints, like whatever the endpoints that we need to do, we need to implement. So this path section contains all the endpoint and supported HTTP methods. So whether it's a get or post or like a delete or patch, like these kind of things, it will be in the path section. This is where we describe how clients interact with the API. So this is when we define this path. So we can give, basically the client will decide, like client will interact with our API using these paths and HTTP methods. So third one is the component allows reuse of schemas. Let's just like in raml we have traits and then fragments and all those, right? So here in OS 3.0 we call it as a components. So in components will allow reuse of schemas, parameters, responses. And this keeps the specification clean and avoid duplication. So in raml we have traits, like, so in OS we cannot have traits. We cannot also have a fragments. So for this one in OS, they came up with a components concept. So when we say components, we can add a request body there under the component. We can also add a response body under the components. We can also add the reusable components in under the component section. So like instead of going like creating crates, fragments, and everything, so we have a concept called components. Underneath that, we'll have a what a all this in a single thing, so we can easily reuse those things. The fourth point is schemas. So schemas define the structure of request and response payloads. It's like a rules. So MuleSoft uses these schemas for validation and data mapping. And fifth one is security. So here security defines authentication methods, like what type of authentication will be required for this OS or particular API. So we'll define the security section. Security defines authentication and authorization mechanisms. This ensures APIs are protected consistently across environments by applying like relevant policies. And at last is like responses. So responses describes possible outcomes for each API operations. For example, if it is a success scenario, what is the output, what is the response it will come from when we are invoking that particular API? What is the, when we say error scenario, when we say bad request, what type of data, like or data issue or any other issue that that we may expect from that API? So these things can be defined under the responses section. So it clearly, this response section defines definitions like improve consumer understanding and error handling. So when some consumer sees the API, so when they invoke the API, they will get to know, okay, for success response, this type of response we may get. When it is failure, like this, okay, this is the failure message we may get when we are invoking a real-time API. So these are all the key components. And also, and what is the best practices for the while we are using API design, while we're designing an API. So first thing is use RESTful naming. For the first thing, endpoints. Like when we say REST API, so we always think of endpoints. So endpoint should use nouns and meaningful resource names. So and when we see an endpoint, it describes what that particular endpoint is doing. So that's why with RESTful meaning is a must and should we need to consider it the first. This makes APIs intuitive and also easier for consumers to understand. So that's RESTful naming. And when it comes to version APIs, so always maintain the version of the APIs while you're doing, because if you are keep on changing or if you are keep on updating the specifications, you should maintain the version of that API, so that for like when someone comes and then two customers are there, so the one customer is needed for the other like previous version, and one customer is needed for like updated version. So in that case, like it won't impact because we still have that version placed in somewhere and we are maintaining the versions. So in this case, like the changes without impacting the existing consumers, we can keep on going forward. So MuleSoft also supports versioning through URI or header-based approaches. And when we say and like the third one is reusable components. So reuse, like always try to keep reusable things, like when we are implementing more than 2 to 3 APIs in a single spec. So reusable schemas and responses reduce duplications, because if the two APIs having the same success response, so we can always keep that as a reusable component. So whenever we need, we can directly get that and we can use it in that particular API or in endpoint details. So this makes APIs easier to maintain and update over time. Whenever we want to update that one, if the two APIs like need an updation, we can update in a single place. That will help us to like update time for each and every endpoint that is in the specification. And and also we need to design a proper error handling, standardizing error responses. Like we have some set of error response codes that we have, right, for when we're calling an API. So if we standardize those error response and improve troubleshooting, so that can also be used for all the REST APIs, like common error codes. So the if we standardize that one, like we can always use that for troubleshooting. They can also help consumers to handle failure gracefully. And at last, not the least, is securing our APIs. Security should never be an like afterthought. Basically, like we should decide which authentication or security we need to update for that particular API to get it secured. Like we have wider authentication methods in MuleSoft, like OAuth, client credentials, and policies should be all be applied consistently to secure APIs. So the next is implementing OS in 3.0 in MuleSoft. So the thing is, like, there are four steps. Like first is we need to create a specification and design center. That is where we are going to implement OS 3.0. Using OS 3.0, we're going to implement our API. It provides like visual editing and real-time validation in the design center. And once we completed everything, once finalized everything, all the details has been included and everything is finalized, that API specification will be published to Anypoint Exchange. So we have in MuleSoft, we have an exchange where we are all storing the APIs in that one, so that can be reusable whenever we want within our organization. So once we finalize that API specification and everything is done, so we were publishing to exchange. So this makes it discoverable and reusable across team. So generate mule flows. So once it is published to MuleSoft, like when we are implementing in MuleSoft, so MuleSoft can generate flows directly from the OS file. So in Endpoint Studio, we can always use this as a, you can also use a OS to generate automatically the flows that we are implemented. So that will, this create like what are all the things it includes? This creates listeners, routers, and basic scaffolding automatically. That includes what are the requests and what are the responses that we added in this spec that can be also be seen in the MuleSoft Endpoint Studio while we're generating the flows from OS. Implementing business logic. Developer can then add transformations and integration logic, whatever according to the requirement of ours. We can implement our live requirement here. This is where Mule really shines with connectors and data view. So where we're going to actually implement the normal business requirements here using a lot of connectors and trying to connect with end systems, and everything will be doing in the fourth phase of that one, implementing business logic. So the next is like sample users API specification. So this is the sample user snippet, sample user API that I created just to just for demo purpose. So here, whatever they explained, I think in previous slides, you can see here. So we have an info section where we have title information, what is the title of that API, and also what was the description. So a sample API, like here, I just added a simple description called sample API to demonstrate OS 3.0.03. So and version is also like what is the API version that we're using. So current version is 1.0.0. So here we can also mention the server list where so what is the URL of this one? What is the description? It's a production server or not? So and also the second part is a path, right? So here the server section is optional. If we can add it, we can add it. Otherwise, it's not required. Just for the demo purpose, I added. And for the paths, so under the path section, you can see I have created a simple user application, user API, right? So that's why I added a users. It's a path, and we also call it as a resource. So underneath that, we can see the get. It's a HTTP method. It's a get method. Like if someone calls, they need to have this get method call users. So here, we can also mention a summary of that particular what is get method and what the user endpoint will do. So here it will list it whenever they invoke a user endpoint, they will get as written a list of user that is stored in somewhere. And well, that's the summary of it. And since it's a guest method, we have also responses section. Here you can see the responses section. We need to mention responses and also the method of that. What is the error? What is the code of that success response? If it is 200, again, what if it 200? What is the response we are going to get? So the description is like we can also add description and what type of responses we can expect in a words, and also the content. And when we invoke this API, so as to what type of data we are going to get is a JSON content, and also the schema we can also mention here. The type is equal to array. So the whatever the type, whatever the response we are going to get, it's array format. And items is like here you can see the $ref is nothing but we are using as I explained the components concept, right? So here, what are the responses we may get? We added it under the component section in the schemas. So it's a user. So this will in order to refer that component section in OS, we need to use dollar reference. This is the keyword to reference the components in the OS. So similarly, I have created one more endpoint with the same thing with a different HTTP method called post. Here in the users, the first get method is just a return, just getting the return like list of users. But in the post method, we are using actually creating a new user in the endpoint. And request body here, since it's a post, we need to send something for creation, right? We need to send the details and all. So for that reason, we have request body here. Since it's a post, the request body is compulsory, so we can have a required equal to true. And with the content, what type of content we need to send to them. So it's a content is application JSON. And schema, again we are added the component section schema user here. So since you can observe, right, so for user for get and post, I'm say using same schemas here because both of them having the same. So I'm just reusing the same schema under the component section. So that will be useful. Again, the responses is nothing but the same thing 201, because when we are creating, we'll get a 201 error code, sorry, status code. Then we are adding user created plus a description. So here, this is the component section that I referred in the previous slide. So here you can see the schemas. Under schemas, we have given a name for that schema as a user. So till this point, component schema user, we need to mention all three, and then we need to use the $f keyword to refer this component section in the actual API implementation. So here you can, what is the schema, right? So it's a type, like it's an object type, and what are the properties inside of it? So we in the properties means what are the things that will come under that object. So ID is a type integer. ID you can also type what is the type of that value that we may get for that ID. It's an integer value. Format is int64. Same thing like name. So name is what is the type you're going to get, the value type, it's a string. Again, for email, it's also a string. So required means in these three, the required things are name and email is the most important thing. So that's why we added as a required equal to name and email. So this is just a simple OS sample example snippet that I added for to show you how we can to create and what are the things we can include. There are a lot. I will be covering in the next part of this webinar. So please tune into it. And finally, we came back to the common pitfalls. Yeah, common pitfalls for this OS. So overloading endpoints, the first point is like one endpoint should do one thing only, one thing clearly. So let's say we have conflicts with, like, let's say in the previous example only we have users like that is doing two things. One is get and one is post. So if you add again patch, again in the more HTTP methods with without mentioning proper things and it has the same endpoint name, so that will create a conflict, right? So for that reason, one endpoint should do one thing clearly, we need to mention for one thing. And overloaded endpoints become hard to maintain and scaling. So it will come into the confusion, like to see, oh, okay, this endpoint is used for getting the user information, also we are using for creating information, right? So like that it will be overloading endpoints. So when we are defining a schema, so we need to define a proper schema, otherwise it will lead into like significant problems. So bad schemas lead to confusion and also the frequent breaking changes. So when we define a schema, it should be stable. if you are frequently changing that schema, it will become very difficult. And also the investing time in schema design pays off long term, because currently now we are very simple, but when we are going with the live projects and all the examples, right, it may get critical. So whenever we are doing it, so it should be a very less time. We need to take less time to implement, um, to identify, like that's how we need to implement a schema so that it can be reusable. So whenever we come back, so if you want to do a change, that will be very difficult for that one to identify and do the change and everything. So, and also the missing documentation. So when we are doing API specification design, so we need to keep as many as possible as a the documentation purpose. We need to add as many information as possible. So lack of descriptions makes APIs hard to consume, and also the good documentation improves adoption and reduces support effort. Whenever someone comes and see if the descriptions and not documentations are not included, that will lead us to confusion, and also they thought like, okay, it's not a very good API, because they didn't understand what the API is. So for that reason, missing documentation, it's a very serious problem. So we need to add as many as possible. And ignoring versioning. So the major thing is like, we whenever we make a change to the API specification, we always need to maintain is versioning. So skipping versioning causes breaking changes in production, because we sometimes, when we did not add the proper versioning, so when we are deploying the production, so that version is mismatched, then it will always cause a very big loss in the production environment. So always plan versioning from the beginning. So coming to conclusion, so to summarize, OpenAPI 3.0 is not just documentation, it's a development tool. So MuleSoft provides excellent support for managing APIs from design to runtime. So a design-first approach improves quality, reusability, and team collaboration. Thanks everyone, and happy to take questions and or discuss real use cases.
Yep, thank you, Vijit. I would request everyone to please raise your hands to ask the question. Okay. Sindhushi, you're first. Please ask the question.
Vijay, my question is, can we use both RAML and OAS in the same Mule project?
For that, no, for that I will say no, Sindhu. Basically, like when a single API kit project cannot use both RAML and OS together. So one Mule application should have either RAML or OS, because when we are implementing API kit router level, so we should always use a single versioning. If it is OS, it can be implemented in using OS, and then it cannot be used at the same time. We cannot use RAML in that.
Okay, thank you, Vijay.
Yeah, thank you, Linda.
Hello, sir. My name is Sachin, and I want to ask, like, how do you reuse request response schema using components?
Thank you, Sachin, for the question. So in OS 3.0, reusable schemas are defined as I explained in the in the previous snippets. Like we need to use the component section in OS to reuse the schemas and also the examples, and and also commonly used specifications under the component section. And also, if you want to refer those reusable and reusable components, so we need to use the $reference keyword in the OS.
Okay, thank you.
Thank you, Sachin.
I have a question as well, Vijit. Like, I need to understand, like, what is the difference between RAML and OS, right, in MuleSoft?
Okay. Yeah. So for the question, like for the RAML and OS, so basically we have RAML, that was the previous version. Still, it is we are using in MuleSoft. So RAML is actually a best choice for Mule only ecosystem. When you say Mule only ecosystem, it's within the MuleSoft. But when it comes to OS 3.0, we can say it's an enterprise and tool. You can say enterprise level. So there we can use in multi-platform environments like multi-team. And when also the one is for RAML, it has a strong support for libraries and reusability when it comes to RAML. But in OS, we can only define and we can only reuse the things like using component section, but not with like we have an options in RAML called tries, fragments, and everything. But when it comes to OS, we don't have that option. We do only have the component section that we need to define everything underneath that. So like in this case, the OS have a drawback of not having that much of reusability compared to RAML. Yeah, so in this case, the RAML is better. And when it comes to RAML, it has a very user friendly OS, while implementing OS specifications. And also when it comes to OS 3.0, it was little tricky to implement specification using OS 3.0. Dheeraj. So these are the major differences between RAML and OS.
Yeah, got it. Thank you.
Okay. Does OS support XML schemas?
For your question, Padma, yes, it supports OS, and also it fully supports XML payloads basically. But I personally suggest, for when we are dealing with XML payloads in OS 3.0, it's better suited for JSON rather than XML structure, because when we want to build an XML structure in OS, it's very difficult to build rather than JSON. JSON is just very simple. But when it comes to XML, it fully supports XML. But as a developer, I felt like XML is more complex to build in OS compared to RAML.
Okay. Okay. Thank you.
Where do you define examples like in OS 3.0?
Yeah, so in OS 2.2, we can define examples in three to four ways. So the first one is we can define an inline example where while we are defining an endpoint or a resource. So in the same line only, we can add an example saying okay, for the responses, this is the one, without referring outside. So when we say example out, that's the first one. When in the second place, we can use the example object. So we can define an examples a keyword. Underneath that, we can define an object contains all the required fields that is for a response. So that's the second option. And in third option, as I just answered, for reusable components, we use a component section in OS. So using that component section, we can add examples, and that can be used in our OS specifications.
Got it. Yeah, thank you. Anyone else who wants to ask the question, please raise your hands. I can unmute. Okay. I guess that's it for today. Yeah. Thank you so much, Vijit, for the insightful session on MuleSoft OpenAPI 3.0. Thank you so much. I hope everyone found this useful. And yeah, that's it for today. Thank you so much for joining.
Yeah, thank you guys. Thank you so much for joining.
Thank you.